Well, let's take a look at one more example using the method of substitution. Now, sometimes you substitute an expression for a variable that has a coefficient, and when you look at what you encounter, you have to use the distributive property to be able to solve. So let's just go dive right in and take a look at this example, which is going to use that method of distributive property. Okay, so we have the system negative 2x plus y is equal to 8 and 3x plus 2y is equal to 9. So again, we use the same steps as we did previously for substitution. We have to be able to solve. Okay, we have to be able to solve for a literal equation. So doing that, I'm going to take the very first equation and I'm going to solve for actual y. So I'm going to rewrite this as y. Well, actually not. Let me go ahead and start from the very beginning so you can see exactly what I did. Leave no stones unturned here. So I'm going to say a negative 2x plus y is equal to 8, and I want to solve for y. That means I must get 2x on the right of the equal sign and leave y by itself. So in order to do that, is being subtracted, I'm going to add 2y to both sides. So that'll be a negative 2x, and let's see, plus 2x. I keep saying y, but I'm talking about x. Plus y is equal to, and I'm adding 2x plus 8. Okay, so again, I want to solve for y. So in order to solve for y, I have a negative 2x. I want to add 2x to both sides to clear it and add it to the right side. Alright, that's a little more reasonable. So here 2x from 2x is going to give me 0, so they cancel out, so that will leave me with y is equal to 2x plus 8. Okay, so now I have my literal equation. So now I can go right ahead and put my second equation, which is 3x plus 2y is equal to 9. So now all I need to do, since I have y, I can substitute y into either one of these equations. So since we have this one, let's just go ahead and do it. We'll just make it fun. Okay, it's not going to do anything but cause us to get better. So we're going to substitute the expression 2x plus 8 for y in this equation. So here that would give us 3x plus 2 times 2x plus 8, okay, and that's going to equal to 9. So you notice what I did. I took this expression, okay, and substituted that expression for y. Okay, I took this expression, substituted that for y. So now I'm left with what we're talking about, distributive property. So before I go on, I'm going to rewrite it, but I'm going to use my distributive property here, and I'm going to multiply times 2 and times 8, the actual constant 2 here. So that's going to give me 3x plus 4x plus 16 is equal to 9. There's my distributive property. So now I'm back to just adding like terms. 3 and 4, 7x plus 16 is equal to 9. So let's go ahead and combine like terms. My like terms here is 16 and 9. So I need to subtract 16 from both sides. 7x plus 16 minus 16 is equal to 9 minus 16. That will easily, 16 and 16 cancel out. That'll give me 0. So 7x is equal to 9 from 16 is 7, but that's a negative 7 because negative 16 is greater. And then I'm going to divide both sides. So 7x divided by 7 is equal to a negative 7 divided by 7. And this will give me, because the 7s are going to cancel, x is equal to a negative 1. 7 into 7 one time, positive into a negative will give me a negative. Okay, so I got my first value here. Got my first value. So now I need to solve for my second value. So how do I do that? I take my negative 1 and insert it. Okay, so I have my negative 1. Let's go ahead and insert it here. Okay, so we have x as a negative 1. So let's insert it in the first equation. So we'll have a negative 2x plus y is equal to 8. That'll be a negative 2, and that's a negative 1 we said is what x is. Let's make sure. I want to go, that's right. Negative x plus y is equal to 8. 2 times 1 is 2. Negative times a negative is a positive. So that'll be 2 plus y is equal to 8. We need to subtract 2 from both sides. Put that constant over here. So that's 2 minus 2 plus y is equal to 8 minus 2. And 2 and 2 is 0 and cancel out. So that'll be y is equal to 2 from 8 is 6. So here we go with our ordered pairs. And in this case, our ordered pairs is a negative 1 and 6. Now, the only thing is to leave us now is just to simply check it to make sure we are correct. How can we check it? Just in the original equation, just find one. Let's take the 3x. 3x plus 2. So we'll put check here. And we will have 3 times a negative 1 plus 2 times 6 is equal to 9. So 3 times 1 is 3, but this is a positive times a negative. That's going to give us a negative 3 plus 2 times 6 is 12 is equal to 9. Let's subtract 3 from 12, 9. So 9 does equal to 9, and guess what? We have found a solution for this system, and you notice we did so just the same as the other one, but we had to incorporate the distributive property to do so. Okay guys, have fun.